Hi, you all just finished a U-Try where you got to graph a system of linear inequalities. So what I gave you all was y is greater than or equal to x and y is greater than negative x. Alright, so the first one, if you just had y equals x and you had to graph that line, well, in slope-intercept form, that would be like y equals 1x plus 0 if you want to think about it that way. So we would have a y-intercept of 0, so it goes through the point 0, 0. It has a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1 to get more points on that line. You also could go down 1, left 1, down 1, left 1, down 1, left 1, and get some more points that way. Alright, then we need to connect our dots to form a line. Since it's an or equal to, we'll use a solid line. Okay, I think I can connect the dots in a relatively straight way. Here we go. There's our nice solid line. Then the next thing we need to do is shade. So do I shade above or do I shade below? With that y is greater than, you might be able to tell we're shading up. But let's double check with the test point. How about 0, 1? That sounds like a nice one. So if I use the point 0, 1, then 1 would be my y, 0 would be my x. And my question is 1 greater than or equal to 0? Yes. Yes, it is. 1 is bigger than 0. So I'm going to shade in the direction of my test point this way. Okay, and I'm lightly shading because I need to do that intersection later. Okay? With the other one, y is greater than negative x. First thing we need to do is that boundary line. So y equals negative x, or negative x plus 0 if you want to think about it that way. We'd have a y-intercept of 0 again. We'd have a slope of negative 1. So that means that we would go down 1, left 1, down 1, left 1, down 1, left 1 as many times as you'd like to get lots of points on that line. Or you can go up 1, right, or sorry, up 1, left 1, up 1, left 1. Went down and right, or you can go up and left. And then this one is going to get connected with a dashed line because it's just greater than. So I'm going to connect all my dots with a nice dashed line. Alright, next up we need to figure out how we're shading. So with y is greater than, you might be able to tell, I think we're shading up. But how about we use that test point again? We are using 0, 1, and you can use any point you would like as long as it's not on your line. Okay? So we just want to see if it's true or not. So with 0, 1, 1 would be the y value, 0 would be my x value, and the opposite of 0 is still 0. So is 1 greater than 0? Yes, it is. So we're going to shade in the direction of our test point, which would be this way. Now we're ready to do that intersection, to do the and. So the and means that we're going to look at the overlap between the two. And where they overlap is this kind of top triangle area. So I'm going to shade that extra dark because that's where my solution area is. Okay, so all of this is our solution. And that's what the solution looks like for this problem.